Thanks, everyone. I'm excited to be back at PyData London. And I'll be talking about PDFs. And just as a quick intro, some of you might know me from my work on Spacey. Spacey is an open source library for industrial strength natural language processing. So it was really designed from day one to be used in real applications and in real production use cases. And whenever you have a use case where you need to analyze lots and lots of text in a way that goes beyond keyword search, that's really what Spacey was designed for. And as open source maintainers, we also always put a lot of work into kind of the boring stuff, like backwards compatibility, making sure we don't just break APIs, break people's code. And that actually had a pretty nice and satisfying side effect more recently, which is that generative AI can actually write Spacey code pretty well. Like if you were here for the for Jay's keynote, you saw some examples of the models actually, looking up how to write code, writing code, and this works pretty well for Spacey. So it's not something we anticipated when we put all that work in, but it paid off. So definitely try it out when you get a chance. And we also publish and develop Prodigy, which is a modern annotation tool for creating training data and evaluation data for machine learning models, and for really building your own AI applications in-house, distilling smaller models that run internally in full data private environments. It's of course fully scriptable in Python, and it was really inspired by a lot of the ideas that I might also be touching on in this talk today. And as you can see, we really thought a lot about practical use cases, how we can make developers more productive, let developers take back control, build custom solutions for use cases. And that's also something I'll be talking about today. And all that stuff, data science, NLP, AI, it could all really be much simpler or very simple if all our data came in as nice, clean, plain text, ready to work with. But unfortunately, if you work in industry, that's not the case. A lot of it is kind of hidden and stashed away in PDF documents, Word documents, scans, all kinds of other formats. And as frustrating as this might sound, there is a reason for it, and that is paper. Businesses really want electronic copies that map to paper documents. And that's really how we ended up in this kind of mess, and how we ended up with PDFs ruling everything pretty much since they became an open standard in, I think, 2008. They were initially slow to catch on. Nobody was using PDFs. But this changed quickly as the standard opened up, as people were able to open the files, send them around as the internet got faster. And ever since then, developers have really been quite frustrated with the different document formats, and PDFs in particular. And I think there's at least one pretty straightforward reason for it, and that's that as developers, we really like to operate from a source of truth, from something consistent that we can develop against. And the problem with PDFs is that PDFs are really a pretty bad source of truth, because saying I have the data in a PDF is about as meaningful as saying I have the data on my computer. Like, it could mean anything. It could be plain text in a document that you just need to extract. It could be a scan, an image of text. It could be a mix of both. The layout features you might have in the document, they might be extremely relevant for what you're trying to do, or they might be completely arbitrary and not relevant at all. And these are all things you can't know. And so I think that's why it's not necessarily that useful to treat the PDF as the source of truth, and much more reasonable to kind of get the stuff you're interested in out of the PDF as quickly as possible. And currently, with more powerful vision language models, it's definitely become finally possible to work with PDF files. There are lots of models and chat applications where you can upload a PDF, ask questions about it, and that's cool. But they still really treat the PDF as the source of truth. I've even heard from teams that ended up converting plain text to PDFs in order to use them with these kinds of tools, which is something you probably shouldn't be doing. But that shows there's still a lot to do and a lot to solve. And I think if we've learned one thing, especially more recently with larger and larger models, is that if you really think about it, at their core, a lot of problems we're trying to solve with NLP are relatively flat classifications. And the only difference is whether you have one monolithic model that tries to do all of it at once, or whether you take it apart into separate pieces. And a lot of these tasks are actually pretty solvable, but they just become a lot more complicated if a model needs to do it all at once. Like, for example, if you want to categorize PDFs, if you have a model that needs to do it all at once, well, you have to open the file, extract the contents, you have to embed it, you have to predict the label. If you're doing RAG, you actually have to find the right document, you have to find the right location in the document, you have to formulate a response. All of that is one model, and if something goes wrong along the way, well, it's very, very difficult to get in there and fix it. But if you take the PDF as a format kind of out of the equation, the task actually suddenly becomes pretty manageable, and that's like text classification. We've done that. We've been doing this for, what, decades. We have existing models for that. We have existing techniques for that. We might not even need like super sophisticated deep learning for that. There's a lot of, it's really a lot of tried and tested methods that we have for that. And so, you know, the idea is, well, what if it just, you know, wouldn't matter where the text comes from, if, you know, it's kind of completely irrelevant whether the text comes from clean plain text, from a database, or from a PDF document. So that's kind of the ideas that we had, and the ideas that went into building something that, yeah, basically it allows us to apply NLP techniques to PDFs, and something that I think started experimenting with last year. And in my research, I came across a library called Docling. You might have heard of it already or tried it already. It's developed by a team at IBM and really directly inspired by some of the real-world use cases with PDFs that they've had. So that's always a plus. And they've also published their own, not only an open source library, but also their own models for document processing. So that was very cool. And one thing I think that really drew me to the library was the unified structured format, the Docling document, that takes the PDF and represents everything that's in the document in one consistent source of truth that you can work with. And maybe I'm a bit biased there as well, because it really reminded me of Spacey's doc object, which kind of has the same job, which represents the text and the document, and always lets you relate any annotation and any prediction back to the whole document and other predictions and annotations in the document. So if you have used Spacey before, you might already be familiar with it, but it felt like, hey, this is like a perfect library concept, and also a perfect complement to what we already have. So it should hopefully be straightforward to integrate. And here's kind of how it looks at the moment. It is all open source. You can try it out if you want. And the library that came out of it, I've called Spacey Layout, because what it really adds is the layout processing capabilities. And just like with Spacey, you can process, in this case, a file or file object, file path with it, and it gives you a doc object, the same doc object you would normally get when you process a text. And that Spacey doc object holds the text-based contents, again, just like you would have with regular text, only that the input is a PDF. And it also contains references to document layout features like sizing. And now the more interesting part is, of course, the PDF or the layout of the document consists of different sections, and they're represented in the document spans, which means you can iterate over those sections. And for each section, you can access the text content, for example, of a paragraph, but also the tokens and the character offsets into the original text, just like you would get for a regular text that you process. There are, of course, different section types. You have headings. That's all stuff that comes directly from the Docling model. And you also have the layout features like the bounding box, so you can relate all of those sections back into the original document and then also access the text for them. And so that actually worked very well, also thanks to the Docling models that, of course, power the underlying extraction, and it all fit in very neatly. And now, of course, even more interesting part of this is that, if you've used Spacey before, you might know that you can't just only process a text, you can also process an already created structured doc object. So that means if you have extracted the contents from a PDF, you can pass them to an existing model or pipeline. For example, here, that's one we distribute out of the box, the transformer-based English pipeline. And you can basically pass it that doc object, and that NLP pipeline gives you the annotations that you would normally also get from processing a text. So that can contain stuff like named entities, part of speech tags, dependencies, grammar and syntax, but also stuff you've trained yourself, like a text classification model, span categorization, or even, if you don't need a fancy NLP pipeline, maybe you've written some rules, rule-based extraction, Spacey matcher rules, all of that you basically apply to the PDF, or you mix it in with plain text. So it really, it's the same mechanism, whether your content comes from a PDF document, from a Word document, or you already have it extracted as text. And because what we're working here with is the great Python ecosystem, and we can access all of that in Python. There's a lot of cool stuff you could do with it by simply just writing Python code. So if you have the structure of that document and you've processed it, for example, with named entities, you can, for example, write code to find the layout span that contains a given entity by just iterating over the layout spans. You're looking at the start and end. And if you're in that layout span, well, then you can break and you know, OK, we found the layout span, for example. That's like pretty straightforward Python code. So in this case, we can look at the first entity, which is Apple Inc. and an organization. And then we can find the bounding box, and we know where that paragraph is in the original document. Or the same logic is also something I used when I played around with a custom attribute for finding the closest heading. Because if you think about it, well, yes, you can do it in a very sophisticated way, but actually the basic logic is, well, if you have some text here and you want to find the heading it belongs to, well, you kind of just go backwards in the document, and the closest heading is most likely the heading that applies to that text. So here, for example, we have the closest heading above the company summary, and we can access that. So that's all pretty cool, and I think there's a lot of opportunities and also ways to reuse existing logic that previously only applied to regular plain text, and just apply that to content that comes from a variety of document formats. And now, I think the number one question when I started working on this that I got was, well, what about tables? Because I don't know. Unfortunately, fortunately, whatever tables are very common in a lot of document formats. And luckily, Docling out of the box also includes a model for processing tabular data. So we were able to integrate that pretty easily. And so if you have a document with tables, you can access the doc._ table. So the __ here, that's kind of a Spacey convention that indicates that it's an extension attribute. So it's an attribute that was added by a plugin by a user, and not something that's built into the core library. But so the Spacey layout plugin adds this tables attribute to the doc. And for each table, you can look at the position in the document, and of course also the data, and what's one of the best formats to represent a table and actually do maths with the table. Well, that's a pandas data frame, and so that's also the conversion it does under the hood. So tabular data, if it's available, you get back added as a data frame, and then you can do whatever data wrangling, data science with it. And all of that is powered by the Docling model that is underlying for table processing. They've also published a technical report and also a paper on it if you're interested in some more details on the table format model. What you get is basically a structured representation of the table. And tables are kind of interesting in the context of NLP because in a way they're kind of what we want. They're structured data without all of the annoying natural language around it, but they still kind of create tables in real world documents are often created by humans, so we don't necessarily know how well they represent the data. It's not always clear what the data actually means. So one idea we had that we've been kind of experimenting with is how do we represent this table in text? Like if you have a model that maybe categorizes text, that maybe extracts stuff from text, you know, a lot of NLP components are really designed for natural language text for sentences. And here you suddenly just have this random data frame in the middle of it. So one thing we've been playing around with is, well, what if we basically take that data frame and supply some logic that converts it to text? Maybe you can use a generative model to take a table and turn it into sentences. Or maybe there's some rule-based logic you can use if you know exactly what's in your table and you convert it to natural language. And then that's represented in the document text. And then you could use that with your existing components. And it would much more easily work out of the box for things like named entity recognition or text classification, because it's just like all the other regular text that you have in the document. So that's something that is possible. We've only played around with this so far, so I'd be actually kind of curious how well it works, if maybe there is an opportunity there for stuff like RAG to basically have your tables represented in the same way as the rest of the text, or especially also for documents where you know exactly what the tables mean, because that's the thing in a lot of industry applications. Like often you don't necessarily want to process anything ever. You know exactly, hey, these are earnings reports, these are those types of documents, and you have a lot of information that you can maybe incorporate in order to make your systems better. So yeah, if you end up trying this out, definitely let me know how you go, because I think it could be a cool idea. But what we're seeing here in general is that having this sort of modularity and having a process where we can combine different pieces and put them together in different ways is incredibly powerful. For example, a layout analysis and doing that separately from natural language processing, which we really have tried and tested methods for, and where we've really been shipping systems and also successful applications in production for a very long time. So if we can build a system where it's really irrelevant where the text comes from, and we can really break it down into individual components and work from a source of truth rather than having completely separate end-to-end monolithic processes for all kinds of different documents. I think there's a lot of opportunity there for to reuse existing logic, and it really maps to how we write software in general. We write individual components that we can reuse and combine. We don't just write completely new code bases for every different format that we're working with. And I think we can do something very similar here in NLP, data science, and AI. So to show you an example of like a more end-to-end workflow here, it's also something I've documented this in a bit more detail in a blog post. I'll also link to that again later if you want to check it out. As we've seen, we have the PDF here. We're processing that and into a structured format that's unified, that we can use as a source of truth, like a doc object. And then we can apply an existing NLP pipeline to that doc object to create the annotations, like spans of text, any kind of information that we're trying to extract from the document. And that NLP pipeline can consume any doc object, whether that comes from a PDF, Word document, scan, which is all stuff you can do with spacey layout and docling, or whether it already comes out of a database and you already have it as plain text. And then, of course, we might have situations where we want to improve that NLP pipeline. Our model will never be static. We always want to have a workflow where we can iterate and make it better. And so this structured doc object that we get out at the end, we can take that, we can annotate it, we can make corrections to the predictions that maybe the model gets wrong, and we can feed that back into the NLP pipeline, or even use that to train our very own model that's completely specific to our use case, using transfer learning, maybe basing it off a model like BERT, because even though there's a lot of talk about in-context learning, using prompts, and that's very exciting and relevant, and that's a lot newer, but it doesn't mean that something like transfer learning is outdated or has been replaced. It's still one of the most, or the most powerful way of using examples and labeled examples in a scalable way. So we can use that to build NLP components. We have some examples where teams manage to really build models as small as 6 megabytes that do a very specific job, run super fast, run privately as well, which of course in a lot of industry use cases is super important. You can't upload your PDFs anywhere. You can't share your predictions or your real-world data with any API. So that's also a very important consideration here. And another thing, another question we can ask ourselves at this step is, how important are the layout features really? Because if we're working with design documents and layout documents with a layout like PDFs, as humans, we might feel like, well, the way they're presented, it feels inherently important, and because that's kind of how we communicate information. But if we take a step back, we often find that the layout might not really matter for the task that we have at hand. And if we completely disregard those layout features in the model, we might be able to create systems that generalize a lot better. Because no matter how the text is, how the content is formatted, we'll still get the same, ideally very generalizable good results. Or maybe if we're dealing with document formats where the layout really is very crucial to the information, or we're dealing with examples where all our documents really follow the same style and the same layout, we can decide to incorporate those layout features into the model and make the predictions a lot better this way. And that is really something we have to decide, and I think we have to consciously ask ourselves. And what really helps here as well is iterating and looking at it. And I think often, as you might have also found out in your work, once you start engaging with the data, that's when you really maybe find edge cases you totally hadn't considered before, or maybe realize that, oh, you kind of have to rethink your approach. And I think the same goes for working with documents and document layouts. And to show you a quick example of kind of the iterative annotation process, this is a plugin I've built for annotation tool Prodigy that also uses spacey layouts, so that integrated pretty smoothly kind of out of the box. And it's based on what we call recipes, so these Python functions. And in this case, we have the recipe function for annotating manual spans. There's the input data, so a directory of PDFs. And then there's also what I've called focus mode. So you often want to limit the process to specific sections, for example, text blocks and list items that actually contain the text, and maybe ignore certain other sections or headlines. So you can basically filter the types of content you want to look at. And then here's how this looks in the interface. So you can see the layout section highlighted in context, and then you have the plain text representation that you use to actually make the annotations on. And that's also maybe where you can really come to the conclusion whether the layout is relevant or not. Maybe you go through this and you realize, oh, actually, looking at the layout in context is really not that important, and I should really focus on the plain text and build something that generalizes very well. Or maybe you find that actually looking at it in context is really important to make the annotation decision, so you should want to incorporate that. And I think that's, in order to make that decision, really engaging with the data is very important, and also getting the text out of the layouted document and really looking at it as plain text is very important. And then the result gets saved to a data set, and that data set is also something you can train on. So in that real world scenario, you can actually provide an output directory for the train recipe, so that's where the model gets saved. You can provide the data set, and then you can run a training experiment and train a model, in this case, with a named entity recognition component. And here that's the evaluation split. That's something you usually shouldn't want to be doing in a proper production workflow, because that just holds back a percentage for evaluation. But that's perfect if you're kind of lazy, if you want to get a quick evaluation result as quickly as possible without creating a dedicated evaluation set. You can just hold back, in this case, 30%, and train a model and see if your model is learning something, because often that's kind of the first thing you want to find out, like, is this actually working? And then you can work on improving it. And so then this gives you this NLP model component that you can use at runtime. Just like I showed you very early on, you can load that back in. With Spacey, you can use a component that you've already trained maybe for a completely different use case before you started working with PDFs, and then you can apply it to it to the doc object that you've created with Spacey layout that uses docling. So that's how it looks, and then you're applying the PDF processing first, and then the model, and of course in a runtime environment at scale. You can also process multiple documents as in batches, which maps to how you would process large volumes of text as well. And so you have a collection of documents, and that's much faster, and also do the same thing analog with the NLP object when you process it with the model. So that's how it looks. And to summarize some of the main takeaways, I think also that came from me engaging with this and trying lots of things out. I think one thing, in my opinion, definitely PDFs are a pretty bad source of truth. And if we really want to have a future-proof, robust system for production and real-world use cases, I think it can be very helpful to get the data out of the PDFs as quickly as possible and work from a unified structured format that's the same, and that really takes the arbitrary document, PDF, Word document, whatever, out of the equation, and do that as early as we can so we have something unified to work with. And similarly, this kind of modular approach, I think, also really maps well to how we develop software and how we actually develop a lot of NLP applications in general. And by breaking up this otherwise very monolithic approach into individual components that work from a unified structured format, we can utilize tried and tested NLP methods and apply them to PDFs. And we won't have to reinvent the wheel and just basically reinvent things that we can already do, and we can already do very well and reliably, just because the data happens to be in a different format. And finally, I think we're still very early on. There's a lot of work happening in the field. Docling is also improving their new layout analysis models. The models are getting better, faster, and smaller already. It runs great on my laptop, and I think we'll see models being even more efficient, so that you can do the extraction process first, and then at runtime, you really just apply the NLP processing, and you have something that runs on your own hardware and doesn't require expensive compute resources, runs totally privately. So I think this, it's an interesting space to watch, and I think with better models, we see even better workflows here. And as I mentioned previously, I did write a whole more detailed blog post on the topic that goes a bit deeper into PDF processing and kind of the process of building this open source plugin for working with PDFs. So check it out. Definitely, if you end up trying it, let us know how you go. It's still quite new and very early on, so I'm always excited about hearing about new use cases and like real world applications. And yeah, so definitely get in touch, and thank you.